Yeah. Hi, everyone. I'm Iakov Seergev. I'm a C++ developer with somewhat 20 years of experience in the field. Just the key words about myself: it started as a hobby, then bioinformatics, then web ads, then speech recognition, telecommunications, and last 7-8 years finance. I'm not a member of standard committee. I'm neither author of the standard algorithms. I'm just a C++ user, probably like most of us, right? How comes that I'm here in front of you? It just happened that I approached Phil after last meetup with an idea that we could probably have meetups as peer discussions. So let's say we choose a topic, and someone presents some introductory talk, and then we kick off discussion. With C++, it's a huge topic. We all come in from different backgrounds, like finance, game development, AI. Let me pretend that I know what it means. So not many things in common in our specifics, right? But we all use C++ as an instrument, yeah, and we all have fun programming C++, as was said in the previous talk. And yeah, Phil actually suggested to talk about standard algorithms. So if it goes wrong, please address all questions to Phil. I would like to make it not as a talk, as I said, but rather like an open discussion. So please feel free. I'd be actually happy if you interrupt me any point and have any ideas on what is presented. As I said, I'm just a C++ user, and I have more questions than answers. So I would rather like talk about the question and try to approach the question, one main question I want to discuss today, and probably add my 2 pence on standard algorithms, and probably you would help to add your 2 pence, and it's finally get a pound. Main question, actually the one question I want to address today to you and to myself is why are standard algorithms often forgotten in practice? We all know that standard algorithms are powerful tools, yeah, building blocks to write in many instances the things we like, and it would be nice if we would use it more often. It would easy to read the code. It actually would be easy to implement, but somehow it doesn't happen so. Yeah, I guess many of us found even ourselves writing cycles within cycles within cycles, doing some regular stuff more or less, and then usually after you submit it for code review, you realize that oh, I could do it in 2 lines, basically using the standard algorithms. I guess it comes from the learning. So when we learn standard algorithms, we dwell on how they're used. So we all know that they operate in the sequences, 2 defined by iterators, mostly. Many have version that takes a predicate, like sort, for example, yeah. Some take an output iterator, yeah, generating the other sequences. Most return an iterator or an element or pair of iterators, the predicate which was passed to the function, or the output iterator. Some modify the sequence, some not. And having like too many of them around, actually, one could argue that they're not enough yet anyway. But it's where we stop usually, yeah, because exactly it's a lot, right? So we know how to read it, and when we come to implementation, we will find what we need, right? We sort of have an idea about them. So they become a part of our passive vocabulary. So we can read them, but we often forget about them when we write. It's not our active vocabulary. And after all, we're all good programmers, and we worry about data structures. We don't worry about algorithms, right? That's a famous quote from Linus. Here I put, I guess, if not all, but the majority of them just in alphabetical order. And I don't know how it looks for you. For me, it looks like a mess. It's overcrowded. Yes?
Yes. I'm very beginner, yes, but from what you're saying, is people not using algorithms because they've been trained to just do everything by hand. And where I'm coming from, the uni, yes, the C++. So every time I ask a question, it's like, can we do more examples of something? People are really, the experience involved, they're really struggling. Yes, and I mean people level of Kate Gregory. If she's like, examples, not really. So maybe it's the thing is, we got wonderful tools. My feel as a beginner, I love algorithms because I don't have to put so much of my brain power to actually think of something. Somebody else with massive experience done that job for me. But shouldn't that be actually applied on the learning stage? Let's have lots of tools, examples, and so on, so people actually, even experienced people, can actually start using those. Because if you start using that, it's like with automatic and manual gears in a car. If you start using automatic and you see how comfortable that is, and you don't have to do all this shifting, you will start using automatic. But if you don't, then you stick with what you know.
Yeah, exactly. I absolutely agree. So it's what I want to claim, that it's actually about starting from the learning phase, yeah. And then we often don't come back to it because it's basics. We all know it, but apparently we don't. Yeah, more examples would help, definitely, yeah.
You missed the algorithms in numeric.
Oh yeah, I didn't include them. Yeah, I mean, it's already overcrowded from my taste.
I'm mentioning this because this is again sort of a gotcha in C++, that some of the juicy algorithms are not in algorithm, but in...
Yeah, absolutely. There are like only a handful of them, right, in numeric. But yeah, extremely accumulate is a very useful function. Yeah, it can be used in many places. So I left them out just because, and also left some algorithms out, which I will come to it later, which I don't think belong to it, like the iter swap, which often related to algorithms, but in terms of the interface, they're not algorithms, they don't operate in sequences, yeah, and for example, yeah. Another thing about the standard algorithms, I think, which does not facilitate their use, is the naming and probably redundancy. So when we look at this list, yeah, we see partition, then we sort of skip partition copy. Yeah, I know what it does. But for me, partition and partition copy, they're actually sort of different. Yeah, partition is what rearrange the elements in the sequence you already have. Yeah, it's change the sequence you have. Just swap which ones which are true, put in front, which are false, put at the back, right? But partition copy is rather a creation. It's like partition in the way it splits the sequence into different sequences and create two new sequences. And in terms of usage, I think the partition copy relates more to copy if or remove copy if, yeah, which creates these two sequences just in two steps, right? But this naming, I think, is sort of misleading, yeah? And yeah.
I hesitate to speak out against, as it were, but I'm really not sure that you're attacking the most pertinent point as to why algorithms are not more widely used, which is basically because historically they have been awkward to use because putting the predicate functions in is difficult. You have to define it somewhere else. import it into your algorithm invocation, and that spreads out your code. So we have all come from a pre-C++ 11 background without lambdas, where to do these things inevitably cause the logic of your code to be distributed across your code. And that's why we haven't done it. Now, with the advent of lambdas, that transforms the landscape for algorithms. And I am sure that with a new generation of programmers coming through education who have had lambdas at all times, rather than learning a pre-lambda version of the language, these things will achieve their potential. The algorithm library, I think, will achieve their potential.
I agree, it's a fair point, yeah. Though we in C++ 11 for quite a while, right? Yeah.
That's very valid point, because I remember myself back in the day discovering this, or like the ugly, remember the boost lambda, that thing, or like the placeholder where you do %1, %2, right? So definitely, they're still around. Yeah, you can define it. Definitely lambdas, your point is excellent, definitely lambdas help. But also I feel very strongly about your point as well, that we need more and more examples, because there are two main problems here. One, the discoverability of them, because there's so many. And there was a talk at Aku, Jonathan Pokhara, who does a very good job of kind of identifying the algorithms. He maps them to like a map, an actual map. He draws a map, like kind of like Game of Thrones kind of thing. And he's like, these are, in this region, they're like your erase, in this region, is your partition, right? So he does an excellent job of kind of giving you an idea of what the sets of algorithms are, but he stops short at examples. So it's like one thing of like, you know, is one thing knowing them, and another thing is like knowing when to apply them, right? Your point.
Yeah.
And the only one who kind of made some really good points was Sean Banner with his no-row loops, because he was the first to kind of show, don't write by hand, look, you can do this thing, or you can do, you know, we need more of that. So I guess both.
Yeah, unfortunately, I haven't heard this talk. Probably you can skip it and go home, actually, because I'm coming more or less to the same point, though it was done probably nicer. Yeah, I agree, but in case of Lambda, I not quite agree, because, I mean, me personally, I use just the local functors to use with algorithms and having, you know, declared just above the function or even within a function. It helps, right? And it's quite descriptive, though, of course, you have to write a bit of more code, yeah? With Lambda, it's easier, but Lambda doesn't give, I guess, anything like new here as a tool. It's just more convenient.
But it does it on inside, in situ, as it were.
Yeah, but when you put in the unnamed namespace a functor and call it nicely, when you know what it's actually doing, then what you have in your algorithm when you pass a predicate, you have actually, you can put the whole sentence, as I used to do, for example. Yeah, you just put a whole sentence and then it reads remove if, you skip an iterator when I don't like them. Yeah, whatever.
Sensible naming, that can be a very descriptive expression.
Yeah.
But it does demand a bit more oversight discipline to organise your functions in advance, and that's what we struggle as programmers to do, I think.
Yeah, I agree with it. Yeah, I agree with it, though I think, like, you know, discipline, we all require the discipline. I mean, I guess in programming, discipline is the most important thing, right? Sorry, yeah, coming to that, I actually try to come to the point that we learn, like, how they're used, but not like when we should use it. Yeah, so it's not, it appears immediately to our mind. When like here I should use partition copy when I need to make two new sequences, like this back insert or whatever, yeah, from these ones, yeah. And then it's not really a partition, right? So we all, when we think about partition, we think about, yeah, swapping these things. But when you're actually splitting them, right, into two sequences. So I don't know how is it for you, but for me, it's sort of contradiction in terms. It's not like, you know, immediately comes up. So I would like to make the claim that the main reason So I agree with your point absolutely about lambdas. The main reason why standard algorithms are often forgotten in practice is that include file algorithm is overcrowded. Because of that, it is hard to learn and even harder to remember. Hence, they don't immediately come into mind when they are needed. It's what I said about the active vocabulary. They're just not in our active vocabulary. About the naming, what I mentioned just recently with partition copy, and it's not probably the best example. They're questionable in terms of the usage, as well as the redundancy. Some of them are more or less the same. So, for example, copy backward and reverse copy. What are the difference? And I would say there's still not enough. But there's, I guess, yeah.
Sorry, I was just going to say that I think part of that is, so I think there are lots of ways in which these things are getting better, and a lot of those are just because people have been thinking about these things and moving them forwards, and also the language is now giving people better tools. So I think the kind of work in the Ranges TS and where that's going, and the stuff done by Eric Niebuhr and Casey Carter and stuff, I think is going to improve a lot of this stuff. And I think in practice, a lot of the reasons, there's just lots of things that, like, when you first try and use an algorithm, it's not kind of how you would expect it to be. If you've been using Python or something, you just kind of write very obvious syntax, and then you try it in C++, and I don't know, say you do a find, and you have to like get an iterator, and you have to go and find out what an iterator is, and then get begin and then end, and then the thing you get back is an iterator, and I don't want this, and then you have to compare that to end. All this stuff is just very complicated. I think the point you're making there about it being overcrowded, I think partially that's because there are kind of things that are conceptually orthogonal that are kind of stuffed into a bunch of different algorithms because we didn't have another way of doing it. But I think the sorts of things they're working towards, like particularly with adapters, means that you can kind of separate out orthogonal concepts much better. And I think like the composability of those things is hopefully going to make a lot of that sort of thing a lot cleaner. I think in terms of the overcrowding of the algorithm, my impression is that that is definitely going to get more overcrowded. So hopefully it will be cleaner in the sense that it will be less overcrowding just for the sake of providing a copy version and all that.
Yeah.
But I think there'll be much more stuff. And as I understand the modules, the way people are thinking of going modules is very much to bring more stuff, like have much coarser granularity imports rather than the current set of includes. So if anything, we're probably going, presumably we're not going to have a separate numeric and algorithm. There's probably going to be an enormous amount of stuff that you import in one.
Which will make things easier and harder at the same time, right? Because we will still have all this luggage from the past, like sort of legacy, which should be deprecated. And we are not very good in deprecating things, right? So I think this is the point where we should sort of revise it, yeah? And it's why basically bringing it up, yeah? Though it was just a kickoff by Phil who said, let's talk about it. I sort of put,
Good question. Is there no tool, something like you have in Clang, and Clang suggests some of the solutions? So for example, if you apply something Clang, highlights and says, okay, we might try to use something else. Is it not a tool which would suggest, let's say, this part of code to be replaced with some of the algorithms?
not that I'm aware of, no.
You mean like a resharpener?
Yeah. Is it difficult?
Yeah.
But if you like to use that, moving your brain they waves and so.
Yeah.
Then, for example, let's say if it tries to compare your code to what is implemented in the algorithm library, and then let's say you have two collections and you iterate always, and based on that you do something, you iterate looks the play in those two collections, and then this tool would propose you to use the product algorithm, which would be what the fuck kind of feeling for anybody who reads the code afterwards that, hey, what the hell does this do with those products? So,
I was thinking more in the sense of like, the places, the GitHub and so on, they've got millions and millions of lines of code. Yes, there is so much knowledge and there is so many solutions which you apply to certain problems. Whether, like, I don't know, I'm not far away from my comfort zone, but let's say the big data and so on, analytics and so on. Isn't there a way to use that knowledge and say, okay, what you're trying to achieve, covers certain algorithms, yes? So people which done similar things, actually they apply different algorithms.
But it's like the problem is catch-22, right? There are no good examples for good reinforcement learning. It's like everyone does it, wrong.
That's actually a very good point, because I think first of all, the compilers guys have a lot on their plate to make better, and it's not probably the first which would come to their mind at all, right? Not on their schedule, I guess so. First of all, I think it's possibly doable, but another thing. What would you do with so many bugs when you actually trying to implement the algorithms? It's one of the things which is bad about not using algorithms, is that you reinventing the wheel, you adding more and more bugs, and then even after canonicalization of the code, compiler would have a hard time to choose what you actually intended to do, right? So that's here in place the remove if would do the job, yeah. I think it's quite hard, yeah. There's also, I'm tempted to come to the conversation about when we come to the point of analyzing the code, which is can be found in GitHub or anywhere else. As a biologist, by background, I'm bioinformatician. As a biologist, study the databases of DNA sequences, find the similarities, and trying to look at the code in the systematic way. There probably on this path would be some tools which would help you to optimize your code and make it better for a reader, yeah? But probably just after that would come the time when we stop actually doing this stuff at all, would do something interesting as AI or whatever, and the whole code would be written by machines. So, kind of a suggestion. What if we had the following? So if algorithm would actually be at the
Sorry, before you get too far on, I think your idea of provoking lots of discussion seems to be working out quite well. And unfortunately, the side effect of that, you don't have a roving mic, it's not going to come out very well on the recording. And it's going to be impractical for you to repeat all of the questions and comments, but maybe you could summarise some of the key points as they come out.
Yeah, okay. I didn't intend it as a movie. So, okay. I'll try to find the middle ground here. What if we had the algorithm as a directory, or at least not as implemented in the standard, but at least in our mind picture, and as a picture in our mind, and split them into logical groups and the way how we should use them, where to apply them. Not that we know how this stuff works when it's already written, but when you think that I need to, rearrange the elements in my sequence, then I would sort of come to reordering. Or sorry for naming, I'm not a native English speaker, and naming in programming is one of the hardest things, and I'm not the best one doing it. But I think that it would be easier to reason about them if they would be put in sort of buckets in the intention use. Yeah.
Sorry.
Yeah, sure.
So let me argue the opposite way then. I'm not 100% the opposite way, but let me argue. So as I say, I think the direction that people are going with modules is that they're going to make them coarser grains. They're going to pull more stuff together. I think there's there definitely is some talk about the idea that maybe you would just have the ability to say import std and get everything. So let's say we're in that world, and then you just use algorithms, as you want to. I think it's hard in that world to then imagine that you would enjoy going back to not even just going to algorithm, but saying algorithm/comparison. So I think I would tend to say, like, there are advantages to coarser or finer grain in the headers, but one of the main reasons that we've had finer grain is basically because you're including lots of text that the compiler has to then compile. We tend to say that the documentation is. I think it's really good to have that separation so that we can reason about chunks of algorithms. But I'd be tempted to say that I would rather have that in documentation and kind of clump all the.
Yeah. I rather mean it as a mental picture of it, right? Yeah. Not just includes. It's just look at it as a pseudocode, right? So it's not actually split and include. Let's have std as a part of a language. You don't have to include actually. That's another possible. Yeah, we can go further. But as a mental picture, as a sort of separation them in the textbook. Whenever you open the textbook in the C++. It's really often very briefly, that this sort would do this with such complexity. That's it.
Sorry, just to add then, I think in Boost, one of the main divisions is modified and non-modifying, and I find that really useful.
It's still a big chunks of, very big chunks actually, So there's more than 80 of standard algorithms, right?
And increasing.
So and increasing, and even if you split them in two, the best case it's 40-40, right? Though it's actually 60-20, I'm trying I was trying to come up with some sort of system here, right? The first is a simple iteration. Most of them are actually which are not modifiable, and one is for each, which is really powerful tool about the learning again, which is immediately forgotten. We do have range-based for loops now in C++ 11. Why do we need for each? I don't see for each often in the code. Probably I'm unlucky. But to argue that it's still useful, the doc won't have many examples, but at least one. Oh, sorry, I missed indenting here. That is actually very useful in case we often need to somehow specially treat the first element, right? And then sometimes you see in the code the range-based for loop, and then there's an if first, which is a bit strange. You can actually do it with the for each, because, smartly enough, though it's arguable, the standard algorithms are based on the range is defined by two iterators, and it does not have to be the whole container, So you can just skip the first one. And I find it very useful for myself, and I argue, in the code reviews, about this usage. It's actually performing quite well. There's no difference with the for, and it's actually better than the for the whole range with if first, The second chunk, let's say, comparisons. So just like the comparison for equality and lexicographical compare, lexicographical compare is forgotten very often, Though it's quite useful. You are not comparing very often a lot of sequences, But it's I guess people are scared of the name, sort of. Lexicographical compare, it means I'm working with words, But you can compare any sequences like this, right? And sort of comparison with some sort of a state. If the sequence is sorted, is two sequences a permutation of one another? Yeah, like in that example, they are all permutations, right? So it's just like change of the order of elements. So for me, it's sort of easier to reason about it. These guys, they compare. If I need to compare, I need to, like, you know, look at this chunk of the algorithms and look if there is like something I can actually use. The second chunk, it's just like, you know, sort of a suggestion, and I was hoping on actually on the heavy argument here that it shouldn't be here, and actually it shouldn't be called like this. This shouldn't be here, and that should be rearranged completely. So it's rather a provocative division than anything else. That's a reordering, right? And they immediately come, yeah, into three like sub-chunks, the permutations, yeah, mentioned just above, shuffling. About the naming again, yeah. So the shuffle is intended to use with include random, right? And random shuffle actually not. Yeah. So reverse rotate, in-place merge is self-explanatory, right? But when we already have it in the chunk just of 7, yeah, I think it's much easier to reason about than we have the whole mess of them. And again, I don't mean actual includes, but just like, you know, textbook chapters, sort of. Removing, it's actually removing, and I've faced a lot of bugs in the code with wrong usage of removing algorithms, when actually people sort of, in terms of unique, it was not once in my lifetime when people think that the unique, after the end iterator, there's elements which are not unique, they're kept there and you can use them, sort of, yeah. No, they're removing that anything which is after the end pointer, end iterator, which returned after which returned by unique, all elements are sort of unspecified what they are, right?
Yeah, so I think that brings in one of the issues. Unique breaks one of the rules that people are now being taught about how to write a function. A function should do one thing. It should either do something, in which case it returns void, or it should calculate something, in which case it leaves its arguments alone. Unique breaks that. And people are being taught to think about functions that either do something and don't return a value, or the other way around. They only calculate and their arguments are const, because we need that for being able to write multi-threaded programs. Okay, so unique breaks that rule. And if someone says, hold on, this breaks the rule, I can't use it. People are afraid of them if they break the rules that they've been taught.
Yeah, but in C++,
I know exactly why unique has to do it that way when it's only being past iterators rather than the whole range. Yeah, I completely understand.
Yeah, but that's argument about all of them. Yeah, but as well in C++, we would like to have probably algorithms with some more fine-grained stuff. You'll not necessarily need to remove this or erase this.
But because it breaks the rules that people are being taught, it feels like it's experts only.
Or we don't actually spend much time to, like students or people who start with C++ don't spend much time on these algorithms, is what I'm arguing in the first place.
But we want them going straight there. We want them using them as you know, we want people to say, the first place I look is pre-existing code. I don't want to have to write this algorithm. It must be possible to do it.
But then we have to make these algorithms easier to digest. I mean, in the mind, right? So another group is definitely, again, reordering, but especially reordering is sorting, right? Though I would think that nth element is also like sorting, sort of, yeah. Though it's not, right? It does not change the sequence, right? It is. It is?
As far as I remember.
Yeah? You see? Sorry.
Change the sequence.
Yeah, I mean it puts the nth element to the nth place, and all the elements less than that will be before it, and all the elements greater than that will be after.
I think it returns the position of that, which would be that value if the sequence would be sorted, was sorted. You can check up on this. But you see,
It says it rearranges elements.
Yeah.
it is. Yeah. Okay, here we are. Then searching. Min element, max element, min max element, which is obvious. So basically, when you put them in these chunks, the names themselves, they start to speak. At least I think so. Because it's not immediately obvious if the algorithm changes the sequence or not, but at least it's immediately obvious what it does. Yeah, I guess I don't need to comment what they do, right? Oops, it's not searching, of course. It's the most obvious. It's a set operation. Though one could argue that includes is a comparison. Yeah, you compare two sets if like this set includes that set, right? So, and that's a bit overcrowded, which is assigning. As you see, I put here some which you immediately skip usually. When you learn algorithms like partition copy, I know what is it, but it's actually, it's actually assigning or initialization. Yeah, all these guys, they create a new sequences, or assign the new elements within the given sequences or output sequence. As well, it's overcrowded, as I mentioned already. Copy backward and reverse copy. Does anybody know the difference? Why do they exist actually? I don't know.
One allows you to copy two overlapping chunks, working backwards through memory instead of forwards. I think that's reverse. That's copy backward. And reverse copy reverses the order of elements.
But it copies into the output.
Copy backward is the same as copy, but it works backwards through memory, so it'll work if the two input ranges overlap.
Yeah, okay. So it doesn't come to me from the name, actually, at all. Yeah, and I think it's,
I think the reason it's overcrowded is because not the right place in the taxonomy. It should be lower level, so you should have the pairings of mutating and non-mutating forms after you've done the other categorizing. And I think it makes more sense.
Yeah, I would agree. And I think some of them just don't belong there. Or don't belong here. As swap, return swap, min max, operating on pair of elements, or operating on pair of containers, or operating on the initialization list instead of the couple of elements. Yeah, and that's actually about it.
You mentioned in the beginning, but there's still a lot of powerful algorithms that it's not an algorithm, like transform, accumulate the new.
Transform, it is an algorithm.
Oh, is it?
Yeah, it is.
Already, why transform an algorithm?
It's here. Yeah.
All of the new stuff they added, they added the map reduce or reduce one in 17.
No, I didn't include it.
Yeah, I don't know what it is. Yeah, that's the problem. Where is it?
Algorithms aren't actually algorithms, they're just loops in disguise. Most of them. There's a few of them, sorting and intention, and a lot of them are just like, you can write them in one or two loops, they're not that complicated. And by the time I've looked up how they work, and if I get anything wrong, I get 2 pages of errors. I've written that loop So if it's up to me, I'd get rid of most of these completely and keep real algorithms, proper algorithms, like that you get in algorithm books. And then put them all in and uninclude perhaps, or 2 or 3 includes.
I wouldn't say that they're just looping because they are quite simple.
Copy did that to loop, right?
Yeah.
Find or something like that, or if or whatever.
Yeah.
The copy does special things. If you give it trivial types, it will use standard men copy for you. You don't have to worry about it.
Well, that's one. That's easy to write anyway. If I know the types, and they're in front of me, I can do that myself.
Well, if you're writing a template yourself, you don't know what types are going to be given.
You don't. So that might be the case. But usually, if you write, if you're writing a reusable template for some library, yeah, depends what you're building. If you're actually
How about the edge cases? So, for example, somebody who wrote those, I suspect they're very experienced, way more than me. They spent lots of time testing and so on, with lots of different scenarios. When you're writing something, and then you have to think about these edge cases.
you do, yeah.
So you're doing the same work, very experienced people done. Where's the logic?
Well, it's because a lot of the time there's other questions you have to find out to think, well, does it guarantee that? So what about when is it thread safe, and things like that come into mind. And what about when, like reverse, if you see one reverse, you think, how does it actually reverse stuff? Even if it reverses in place, does it copy first and then it copies it all back, or does it swap it in place? Because that might make a performance difference in your code. You think, well, actually, I couldn't afford to copy it because it's quite a large amount of memory.
But using the algorithm thing is quicker for you than...
It's quicker to get it working. Yeah.
So you can apply, and if you see there's some problems, you can then, okay, that doesn't work for me. I have to do manual work, and then you spend a day, a week, whatever, yes, then create your version. Isn't that be a little smarter?
Well, you're saying that you might get a problem come up later, rather than just having to spend a little bit of thought on the edge.
What I was saying is like...
I mean, I'm not saying I'd get rid of all of them. I mean, someone who wouldn't write your own source, use that, wouldn't you? But copy. I mean, it's not that complicated.
But that's the whole idea. People are writing so many copies that here you go with the one copy to rule them all.
Actually, now I start in. Now I started to regret that I removed a couple of slides where I just put basically the algorithm and its implementation aside. Definitely you can implement all of them. Yeah, probably you won't bother about sorting, right? Though, like using merge and using partitioning, you can implement your own sorting. Why would you do it? Actually, that's the problem you're raising is, I guess, is that they are not in our active vocabulary. We always have to think what is actually behind. But if we had them as like words in our language, like actively using words like real building blocks, there would be less questions. And actually, I thought it's sort of obvious. Then the code would be easier to read. And after all, a part of the performance, and we in C++ all for performance, we are writing programs for ourselves in a week or two, right? And yeah, it's easy to implement this remove if, and it's not so complicated. It's going to be like 5-liner, 4-liner maybe, but you still have to think about it, what they do, these 4 lines. And when you combine it with another algorithm like next to it, then you have already 10 lines, though you could have just 2 and they say all, So the code would be concise, easy to read. You just been. Yeah.
You just touched on another problem with the algorithms as they're currently defined. Because they're based on iterators, they don't compose. So you can't sort of chain the output of one iterator, one algorithm onto the next one. Hopefully ranges is going to give us that capability.
Yeah, you mean sort of pipes, right? Yeah, that would be nice. So those you still just
shut
out.
in further defense of algorithms, I I mean, obviously, it's untenable, but I like them a lot. And I think one of the things I like is, I mean, for example, millions of times, a lot of times in my life I've written, essentially finding the max of something or finding the min of something. And so that's very simple. But I just find if I write a little min element call, I'm much less likely to write a bug. And obviously I shouldn't write a bug, but still, if I write min element, it's really, really hard to write a bug. Whereas if I write it myself, there's some non-trivial chance. And then when I come back to that, I mean, yes, it's only like a couple of lines of code or something, but still, when I come back to that, I find it's much easier to parse, like as I'm skimming through, and there I'm just grabbing the minimum of that range. Particularly, so obviously, at the moment, it's reasonably verbose as an algorithm call, but as you're moving more towards kind of the modern range of stuff, like Eric Never's library might be, it's getting, these sorts of calls are getting more and more concise, so I'm kind of finding that if I use a standard algorithm in modern, with one call, it's just very, very clear exactly what I'm doing. And also, there's just like no non-constant variables that we're just incidental things in the calculation that just makes code very kind of expressive and clean.
I certainly agree with you on the conciseness because often it makes the code bigger when you use the algorithms.
Yeah.
Yeah.
This is definitely improving.
It's still included, or you have to put std before everything. That starts making it chunky.
Just imagine. Oh, sorry.
More concise. I think that's definitely a good argument.
Just imagine you have here with lambdas or without. Yeah, you could have a local functor there, or you have a lambda which is called is odd, or if is odd, if odd. Yeah, and then you copy if begin end if odd, right? So you copy only odds. Yeah, and it's coming to the const west and east. It's English language afterwards, yeah. So we can speak English, though I can't, but many of you can. Yeah.
Just to pick up on the turn of phrase earlier, that some of these algorithms are just loops in disguise. I'd actually turn that around and say that actually loops are just algorithms in disguise. And that's really the point of this. We're just raising the level of abstraction into our more everyday vocabulary.
Yeah, but the issue, what you mentioned before, that algorithms are not non-composable, I think that's a big issue. Cause, I mean, the thing is that usually when I have a big data set and let's say I want to find the min element, I also want to do something else on that data set too. So then I will decide, okay, why would I iterate over this twice or even more times? I just write a loop where I find the min, do whatever magic I want, and in addition to that, so.
Yeah. In the gentleman's defense, there's one thing here, especially that we are in game dev here, right? So don't underestimate the unwillingness of some departments to kind of not use it, because, for example, even copy, right? To some extent, it's a black box that you kind of have to trust, right? When you're bringing it in your own super controlled environment, especially if you're like us in game dev or like embedded, right? And historically, it wasn't like now. We're living quite good times when these are quite straightforward. But historically, it wasn't the case, or like a copy on Windows wasn't the same, generating the same code as, let's say, Linux. And even so, again, the black box idea, right? So it's like, have you seen the implementation of the STL on the Windows, the thinkware? That thing is unreadable. So you can, to prove how simple copy is, and you try to go, and it has a million of like abstraction layers to aid the debuggability. So sometimes, like the gentleman was saying, sometimes like even a copy kind of looks kind of daunting, and you're like, screw it, I'm gonna do my own loop here because I have ultimate control over it, right?
Yeah,
I'm not advocating that, but that's like quite a something to have in balance.
Fortunately, I haven't seen Windows for ages.
That's the point of things like even something as simple as std copy is that there are lots of optimizations that can be made, and that really the whole point is you don't need to look under the hood. You look in the documentation to see what it's doing. If I were to sort of take away any meaningful variable names from merge sort or quick sort, I don't think I would be able to recognize that algorithm as saying this is sorting.
Yeah,
I see a call to std sort.
The implementation though.
It's sorting. I see a call to stable sort. Great, it's sorting and maintaining order. it's just clearer what's going on and faster because
Not necessarily
people have
faster.
optimized
That's
it.
one of the things that actually is funny.
Okay.
Also, every
I
time
doubt
you
it'll be
implement
slow.
for the exact project that you have, you always have a way to actually fine tune to what you want. And it's the generic algorithm sometimes cannot reach that. So sometimes they're still used. I do think that Tom is correct. You just implement on the generic way, and only if you need you go. So you should have the dialogue to actually know the algorithms, and if you need, you have to go faster. But ideally, it's usually good enough.
Yeah, it's still good enough, and after all, if you care about performance, measure, right, and then replace it with what is faster if you find faster. Yeah.
All right.
Huh?
All right, Woods. Well, but then, okay, let's remember the case with map insert. They used to allocate memory, and this was fixed, but still, this was a big thing.
Yeah, sure. But
Standard map.
The step map was implemented with a mutex in it.
yeah. Yes.
Well, I was referring to something else. The insert method used to allocate memory, even though, and it's because of some requirement in the standard. It doesn't make any sense. As a user, you would never expect the insert method to allocate memory, but it did.
Insert in
Stood map.
insert in stud map. So you add an element,
Yeah.
and why it wouldn't allocate the memory?
Huh?
Why wouldn't?
Memory above and beyond the
It
memory.
allocates memory on the heap, a temporary variable on the heap. And in game dev, I mean, like we used to pride ourselves with having no allocations during the entire frame. And now suddenly some insertion method allocates memory on the heap.
I mean, if you call insert, you sort of expect that it could actually end up in.
No, temporary
So I mean,
variable.
it wasn't going through your allocator.
Yeah.
It was just.
No. Yeah. Oh, yeah. I got you. Yeah. I thought that I'm completely sort of yeah.
It was not. It was not.
On Windows.
Because of the-
On Windows, right? Or just to
No,
make
it
sure.
was required by the standard. It was everywhere, even on Linux.
Okay. So if I care about performance, I would use map at all, like as,
Yeah. You would write your own containers. You would
Yeah.
write your own library, and that's what we used to do.
No, you'd use a stud vector. So it's going
Yeah. Yeah, I wouldn't use map. No.
And you can use standard algorithms on that. You can, if it's sorted, you can use lower bound, upper bound, equal range, those sorts of things, all coming straight out of the standard library.
Right,
Just
but
what-
okay,
just
but
what I've said. But,
So-
I've said that now you're taking control. You're not using split map. You're saying.
Yeah, but that's a choice of data structure, not a choice of algorithm.
well,
Yeah.
let me contest that. What if I want to control my memory allocations? I cannot use vector.
You can because you can use a stud allocator to a vector. You can pass your
Well,
allocator.
what if I want? What if I?
Also allocate.
What if I don't like the stud vector resizing?
Yeah, okay. We sort of go aside. What is your point? Like, yeah. Sorry, you.
Just a completely different subject. I was just curious as to show of hands. Who's used Eric Niebler's Range V3 library?
I thought it did, but the compilation ban.
Yeah, the compilation code is not ideal, and you can't use it on Windows yet. But it is hopefully what the algorithms library will become.
Can you say it again?
So Eric Niebler is one of the guys who's behind the ranges proposal, and he's written this library called Range V3, which is the prototype. It's
Okay.
what he wants to put in the standard library, and it's brilliant. And it has these things called views, so you have lazy evaluation, and you can compose. You can even overload the pipe operator, so you can literally see your data going through these different steps. Some of that hopefully will come in C++ 20, probably not all of it, but yes, if you want to glimpse the future, then have a look at Range V3.
But for these things to develop, whatever, it needs to be on our fingerprints, and that we need to generate a demand, right? Then it's gonna be sort of, the mess can be cleaned, right, and may become better, whatever.
But I think that the V3 actually solves one of the problems that we have in scope, because then you have a view and then you have the operations and you can compose them in a more... You need less operations to do the same type of complex problems.
Yeah, but most of the time we say, oh, it can't do what I want, or not exactly what I want. It can just, in case it allocates a memory or whatever, I will write my own. Yeah, it's what you usually do. And it's what we have to change sort of our attitude towards it, I guess. No.
I mean, if we don't care about performance, we could write more stuff in Python.
Yeah, sure. But performance argument I don't buy here, because actually, I mean, if you use it in the right place, the performance matters. I personally work for quite a while in HFT, where there's high frequency trading, where latencies are quite important, and I use standard algorithms. And I actually measure the performance in comparison to whatever I can.
Do you use standard algorithms with the standard containers, or do you have your own containers?
Vector is a good container.
I was super surprised when I saw the LLVM talk by Chandler Karut. So LLVM, all are good, but they do their own containers. So I probably shouldn't speak about it here. Yeah. But
it's being proposed for the standard as well.
Sorry?
Like a small vector optimized vector is being proposed.
No, but I think LLVM goes to the extra mile. They have an equivalent of the STL containers for pretty much everything.
You mean where they actually save something on addresses, add some bits in front, whatever? Yeah.
So that's how they bridge the C++ to C standard areas. So they kind of transform everything to low level.
Yeah.
They need some extra control.
I mean, if you're struggling for performance, of course you go wild. But what about 80-20 rule, right? So 80% of your code can be definitely written in standard algorithms, and even if they don't perform as well, you won't notice it.
Still, I think there's some headway into people embracing algorithms. So here in the company, we work with this thing called Ariel Engine, and this thing is a juggernaut. It's been started in the late 90s, right? And because it was started then when STL was not as
maybe age
today, yeah. And all they implemented. So they invented their own containers, right, for everything. It's not the STD vector is TLA, it's not the STD map, it's TMAP, whatever, right? So they continue this all throughout, and they have massive legacy and millions of dollars now. It's too late to change it, right?
We all know about it, right? Yeah. We all know about it.
So they have the containers. They added support for some kind of lightweight equivalents of the iterators. But still, some light at the end of the tunnel. So they still you cannot do max element of their containers because the iterators are kind of broken, right? But still, they respect so much the algorithms that they recreated them themselves in their own namespace. They have an algo namespace when they have find, min, max, rotate. So they kind of kept the spirit of it with the same names, just in a different namespace, working on their own containers.
Yeah, it's
the idea overall of the standard algorithm is still kind
job
of
security, right?
Also, but I'm saying that people are kind of the spirit behind it is still valid and respected, I guess.
Couple more points. One, so obviously we're going to talk about whether we opt into standard algorithms and standard containers, but I guess it's kind of worth just reminding us. It's pretty cool that we can choose to not use standard containers but still use standard algorithms, or vice versa, and the whole step-off vision really does work. We can kind of, like, say we're not using any of it, we could like opt into the standard algorithms first, and then later on switch to that's what people. Also, just remembering, like, when I was first trying to do C++ and not understanding what my compiler was telling me, I think a huge problem with standard algorithms used to be the error message you used to get, which just worked absolutely poorly.
It concerned any STL thing, right?
So I think that has got better. I think partly because they've made the libraries, they've kind of thought about that a bit much more in the library design, and also compiler error message is generally much, much better. But also that is a big area where they're working. So I think the C++ 20 stuff that we're going to get for ranges is going to be fairly limited. But I think a lot of that is because they've like really been putting in the groundwork to make it all use concepts and think that through very, very coherently. So I think that will mean that error messages should hopefully, particularly once the compilers get good context error messages, the error message you should get for passing in something stupid to an algorithm should be really clear. Like, you can't use this sort algorithm because you provided a type that doesn't allow me to do this, which would be fantastic. And I think that will really help people that are coming into C++ find these things more acceptable.
Yeah. I think it worked, sort of, right? I mean, like, sort of discussion format, yeah? I don't know how it will end up on the camera, but personally I don't care much, actually. Thank you very much.